Hi everyone, my name is Bharat Kumar Velugu. So today in this video I'll be walking you through an interesting experiment that I ran on two algorithms to solve the closest pair of points problem. We'll compare the brute force method with the divide and conquer approach, and we'll assess how they perform as the size of the data set increases. So let's get into it. So you imagine you're given a bunch of points on a 2D plane. So and the task is to find the closest pair that is next to each other based on Euclidean distance. So it sounds simple when it is a mathematical computation, but when you want to perform through algorithm-based approach, mm, it's quite a bit complex. Uh, these two methods, let's compare this. First, the brute force method. This one just compares every possible pair of points and picks the closest one. So, simple logic, but it becomes complex when as slowly input size grows. So that's where the complexity gets in. So the time complexity of the brute force is 0 of n squared, and the second method is the divide and conquer algorithm. So this approach splits the point set recursively and combines the result to achieve a much better time complexity, which is 0 of n log n. So to test this performance, I generated random 2D points for different input sizes. They're ranging from 10,000 to 55,000 as shown in the terminal here. So each test case was run 10 times to calculate the average runtime. So I also captured all and plotted the results to visualize the differences more clearly. So so the brute force algorithm start at around 10,000, 3,390 milliseconds for 10,000 points and quickly balloon to over 12 seconds for 55,000 points. So meanwhile, the divide and conquer algorithm started with a very growth rate from just 60 milliseconds to 431 milliseconds for the same input sizes. So this plot shows this clearly, while brute force curves sharply upwards and divide and conquer remains much flatter and scalable. So uh, let us check the plots as well. So when you click on the plots, so here are the brute force versus predicted runtime, and the second plot is divided and conquer versus the predicted. So now let's compare the both the methods. So which is empirical comparison. So brute force versus divide and conquer. So this plot shows this clearly, while brute force curves sharply upwards. Divide and conquer remains scalable and flattened. So I also compared the actual runtimes to theoretical problem predictions. For both algorithms, the expected curves 0 of n square for brute force and 0 of n log n for divided convert. This validate the implementation and come for the complexity classes with real data. So to wrap it up, the experiment proved how critical algorithm choice is. Brute force is easy to understand and works fine for small inputs, but it's quickly becomes impractical. Whereas divide and conquer, on the other hand, is reliable, scalient, and efficient, and is clearly the better choice for larger data sets. So this experiment was a great way to combine theory with hands-on coding and performance analysis. So thanks for watching. If you found this helpful or interesting, leave a like and consider subscribing my channel. Thank you. Catch you in the next one.